Now can you hear me? Yeah? All right, all right. So just let's wait for 2 minutes. Some people are settling down. How was midterm? Midterm examination? Good? All right. Medium. Some people say medium, some people say good. Okay. How much? Who said good? May I know? Which class? Which college? Someone said good, right? May I know which college and which class? Nipani 20. Nipani 20. How much marks you got? Maths only. 80 on 80. Very good, excellent. What about other subjects, if I may know? Chemistry, physics? Yeah, क्या? What about physics? Oh, okay. Physics is bad. Chemistry went low. All right. Maths is really good. Other people? Anyone who did good? 75 above in maths? How many 75 above in maths? Can you please raise hands on 80? All right. No problem. It's okay. So, so today's class. So before starting today's class, do you remember me by any chance? No? You don't know me? All right. No, is it? Yes, no? Okay, fine. I used to take classes earlier, all right? Fine. So, yeah, no problem. So, what we'll do in today's classes, I think sir was doing vectors. For how many of you vector algebra is ongoing, not done, completed? Can you tell me, please? Ongoing? No. Sorry? Completed. Which college is completed? St. Joseph is completed. Other colleges? Nipani, Raibag? Nipani also completed? Alright. Raibag? Okay, for everyone it is completed. Okay. So, sir is doing vector algebra. So, sir told me to do few problems on few of the topics, which I'll be doing today. Alright. So, before going into vector algebra, here and there, wherever shortcuts are required, wherever fast calculation needs to be done, I'll just be helping you with that. Clear? Because obviously, from CT point of view, calculator is not allowed. Since the calculator is not allowed, you need to be fast in your calculation. And some of the frequent calculations that you come across where you need to calculate using one or the other traditional methods, I'll be helping out how we can use a shortcut for fast calculations. Probably I'll take up only 5 or 10 minutes for some of the calculations, and then we'll jump into vector algebra. Okay, then we'll jump into vector algebra. Now, when you come across some multiplications, so as I told you, we are just trying to understand some shortcuts for fast calculation, just with numbers basically, shortcuts for fast calculations. Now, especially when you're dealing with numbers like, say, 35 into 45. Any idea what is the answer? You'll do with the normal method, right? You go with the normal method of multiplication. Does anyone know a shortcut? Please respond. If you know a shortcut for this, please do respond. Okay, no shortcut. All right. So what happens is, especially when you're dealing with numbers where the units place of both the number is what? Units place is 5. Units places 5. All right. And more importantly, these numbers are two consecutive numbers. 3 and 4 are consecutive numbers, one after the other. All right. What we do is 5 into 5 is 25. 5 into 5 is 25. 3 into 4? 3 into 4, 12. So the answer is going to be 1225. Okay. So it works when when you're dealing with numbers like 35 into 45. So what happens with 55 into 65 then? 5, 5, 25. Yes. 3, 6, 3, 6, 30. All right, a very simple way so that you can avoid the normal calculation procedure. All right. So even if you go with higher numbers, it still works the same. Say for example, I talk about 115 into 125. So 5, 5, 25, and then you need to go with 11 into 12. 11 into 12 would be how much? 120 plus 12, 132, right? It would be 132. So what is this? As I told you, this is going to be basically, this is nothing but 3 into 4. This is nothing but 5 into 6. And this is 5 into 5. Clear? All right? One thing. The next thing, you very frequently come across numbers which are perfect squares. Numbers which are perfect squares, and you need to find out what's the perfect square of that particular number. What is the square root of that number? Let's take up an example. So I have a number here. The number says it is 6084. The number is 6084. Now, if this number is a perfect square, so whatever technique I'm teaching you now works out only if it is a perfect square. If it is a 4-digit perfect square or 5-digit perfect square, let us now be comfortable with 4-digit perfect squares. If it is a 4-digit perfect square, how will you find out the square root of this number? You'll go with the normal procedure, right? I think you go with this procedure, am I right? 6084, you club this, you have learned this in 7th or 8th grade, 8th grade maybe if I'm not wrong. And then you find out the square root, am I correct? Yeah? Then you'll tell me, sir, this is from 8th grade, we don't remember that also, you'll tell maybe, right? Yeah, I'm not sure if you're very aware of this procedure. You had this procedure to find out the square root. So as I told you, now I'll be telling you a very quick method. In less than 20-30 seconds, we can directly tell the square root of these kind of numbers, which is perfect square. As I told you, this works out only if it is a perfect square. 6084. Now, I think you're very aware from 1 square until which number? You're very quick with 1 square to maybe 20 square, yeah? Yes, 1 square to 20 square, you're very quick. And I'm very sure 1 square to 10 square, though, you're even more perfect. There's nothing to think at all. You'll quickly tell the answer. Now, what is 10 square? 100. 20 square? 400, huh? And so on, correct? 900 and so on. That's very simple, because if you know 1 square to 10 square, obviously you will write all these numbers. Now, if you look at 6084, we need to decide it lies between which two perfect squares. Now, 60, before this is 4900. 4900 is what? 70 square. Do you agree? Yeah? 4900 is 70 square. And after 70 square, which is the next one? 80 square. How much is 80 square? 6400 is 80 square. Now, first thing you need to figure out is 6084 lies between which two numbers? So it lies between 70 square and 80 square. Do you agree? It lies between 70 square and 80 square. So if 6084, if it is supposed to be a perfect square, the answer for this should lie between 70 square and 80 square. Do you agree with the first point? Yeah? Did you get this point? Yes, you got this point. Now understand carefully. So now it has to be between 70 square and 80 square, which means it either has to be 71 square, 72 square, so on until 79 square. The next thing I need to focus on is the 4. The next thing we need to focus on is the 4. When will it end with 4? So 1 into 1 will end with 1. 2 into 2 will end with units place, 4. 3 into 3? 9. 4 into 4? It will end with 6. I'm just writing the units place. 5 into 5? 5. 6 into 6 ends with 6. 7 into 7? 9. 8, 8, 4. 9, 9, 1. Yes, and then 0. And then 0. Now, if you observe, when does it end with 4? Either if it's ending with 2 or if it's ending with 8. Correct? So the answer would be either 72 square or 78 square. Now I have reduced my options. The answer will be either 72 square or 78 square only. The reason is being why? Because it is ending with 4. Did you get this point also? Yeah? Now we'll directly go to the answer. We just directly go to the answer and cross check. Now if you look at 6084, this number, is it closer to 4900 or is it closer to 6400? It is? Yes. So which one will you pick? I'll not pick 72 square because 72 square will be closer to 4900 and 78 square will be closer to 6400. So if it is a perfect square only, it is gonna work. If it is a perfect square, directly you can check whether 78 into 78 will give you 6084 or not. You can directly reach to the answer. Are you getting my point? Yeah? Yeah? Shall we take one more example just so that we become more thorough with this? Yeah? Yes, let's take one more example. So next you have, say 3249. 3249 lies between what and what? That's the first thing you need to check for. It lies between, lies between 10 square and 20 square, 20 square and 30 square, like that you need to decide. It lies between what and what? It lies between 50 square and 60 square because 50 square is how much? 50 square is 2500. 60 square is 3600. So the number lies between that. When will it end with 9? When will it end with 9? 7 and 3. Correct? It will end with 9 when it is 7 and 3. So it either has to be 53 into 53 or 57 into 57. Are you understanding? Because when you do 53 into 53, 3 3s are, it will end with 9. When you do 57 into 57, it will end with 9. 7 7s are 49. It is closer to 2500 or 3600? 3600. So what will be the answer? 57. It is going to be 57 square. It is going to be 57 square. So when you more oftenly use this, you become very quick with this. You become very quick. Does anyone have a calculator? Does anyone have a calculator? No one? I just want you to give me any number, any 2-digit number. Any 2-digit number, a perfect square, like 67 into 67, something like that. We'll try to answer quickly. Can you give me anyone? Tell me, St. Joseph has a calculator. 77. Sorry? 77 into 77. Illa pang helbedi. Give me the 4-digit number and then I'll tell you the perfect square. Give me the perfect 4-digit number. I'll tell. Sorry? 5929 lies between 70 square and 80 square. It should either be 73 square or it should either be 77 square. Answer will be 77 square. Do you agree? Yeah? Whoever gave me 5929, is it correct? Any other number? 9801. 99 square got ಹೋಗ್ಬಿಟ್ರಿ ಅಲ್ವಾ? ಆಮೇಲೆ 3364 lies between 2500 and 3600. When will it end with 4? Either it has to be 52 square or it has to be 58 square. Is it closer to 3600? So it has to be 58 square. Am I right, dear? Whoever told me the question? Yes. So what am I trying to say? Once you use it very often, you will become very quick. Head up. I think from Nipani someone wants to give a question. Yes? It will work even for 3-digit numbers. It will work even for 3-digit numbers also. But for 3-digit numbers, it depends on you know from where to where. If you know till 25 square, if you know the answers till 25 square, do you know 1 square to 25 square? Or 1 square to 20 square or 1 square to 30 square? It depends on that. It depends on that. If you know from 1 square to 20 square, then we can give the answer until 200 square. If you know from 1 square to 20 square, then if you give me any perfect square until 200 square, we can give the answer. You're getting my point? It was just a quick method, nothing else. I know that you will know this method of solving. You will know this method of solving. But what will happen? It will take more time. And as you can see, we are reaching to the answer in less than 10-15 seconds. I hope you understood. Yeah? It will definitely help whenever we come across a perfect square. Huh? Anyone? Any? Huh? Helappa. Sorry? 35 into 35 into 45. We did that, right? So what happened? 35 into 45. So 5, 5, 25. 3 4s are 12. Answer is 1575 now. 35 into 45 madidra?
1575.
Wait. 5, 5, 25. 3 4s are 12. Wait. What is, just give me the calculator, what is 45 into 55? I might have missed one thing then. 45 into 55 nodipa calculator alle? Just check. 2?
2475.
2, 4, 7, 5. Okay, probably I've missed one thing. You have to go one additional number. My bad, sorry. So whatever number is given here, if you go one additional number, it becomes how much? 3 5s are. Is it 1 5? How much was 35 in, sorry, 1, which was 1 5?
75.
1575. What is 45 into 55?
2475.
2475. Okay, I've missed something maybe. Just one moment. 15 into 25. 15 into 25 ಎಷ್ಟು ಬರುತ್ತೆ? 5 5 25. Okay. Okay, I'll just get back on this. I think I've missed one short thing in this. I'm sorry for that. I've missed something. There is a trick similar to this. Check ಮಾಡಿದ್ರಲ್ಲ 1575 ಬರ್ತಿದ್ಯಾ? I'll just check with this pa. I think I've gone wrong somewhere in this. Okay, in this particular trick. I'll just check with that. Clear? Whoever answered or corrected me or checked or told me that I'm wrong, thanks for that. But I'll check. There's a very similar trick. I think I've not told it properly. Okay? I'll just look into this particular part. All right, students? I'm not able to quickly figure out where exactly is the thing. 45, 5, 5. 3 4s are 12. ಆಮೇಲೆ first digit of 35. ನೋಡ್ತೀನಿ pa. I'll just check into it. I'm just missing on something. We have a trick like this, but sorry for going wrong on this particular trick. All right? I'll just look into that. 1575. I'll just look into that. Okay? Fine? Yeah? I'll correct that thing and I'll tell it to you in the next class. Tomorrow also I'll be taking the class. Whatever correction, I'll tell it to you though. Thanks for correcting whoever it is. Okay? So, here we go. Is this fine? Yeah? We'll go on one more. Huh? Yes, please. Okay, fine. Yeah? Yeah, if anything, please let me know. If anything, please let me know. There's nothing wrong in this trick though, alright? This trick is definitely correct. Alright, that trick, I have not told it in a while. That's why something is forgotten. This trick, we use it very often, or I use it very often. The previous trick which I told you, I have not used it in a certain time. I have not used that 15 into 25. I have not used that particular trick for quite some time. So something has gone wrong in my head itself, basically. Okay. Now we'll go one trick on factorization. So factorization also we do it very often, right? Factorization also we do very often. So what happens in factorization is, you know how to factorize. There's nothing wrong in that. Say for example, we have x square minus 5x plus 6. So what happens when you factorize? What is the quick answer for this? Yeah? 3 and 2. 3 and 2. So just one thing before going ahead, what we do? We write minus 3 and minus 2. Am I right? Yes. So whenever the coefficient of x square is 1, whenever the coefficient of x square is 1, answer will be directly, change the signs of this. Answer will be x is equal to 2 and x is equal to 3. So once you write this, you can directly write the answer, provided what? Provided the coefficient of x square is 1. Provided the coefficient of x square is 1. Okay? Yeah, provided the coefficient of x square is 1. I was still trying to recall, yeah? I'll tell it to you tomorrow what has gone wrong in the previous trick. Anyways, so say for example, you have x square minus 10x minus 24. What will be the answer? So when you split minus 24, what will you write it as? 12 and 2. What signs for 12 and 2? Yes. No, 2 is minus, Allah. 12 is minus. Minus 12 plus 2. Because I want minus 10x. And what will be the direct answer for this? What is the direct answer? X is equal to 12. X is equal to minus 2. Alright? This trick works out. Directly you can write the answer based on this. You just change the signs and write the answer. This trick will work out only if the coefficient of x square is 1. Only if the coefficient of x square is 1. Now what we'll do, what happens when we come across bigger numbers? When we come across bigger numbers in factorization, how do we do it is the question. Okay? I'll take up an example. Okay? So say for example we have, I'll take a bigger number. Say for example we have x square minus 3x minus 1404. What happens when we come across these kind of numbers is the question now. Okay? What do you generally do? You go with the factorization method or you go with the formula method. Am I right? You go with factorization method or formula method. Again, let me give you a quick answer for this. Now, again we think on the same lines. 1404. 1404 lies between what and what? Which square and which square? Lies between 30 square and 40 square. Okay? We are not finding out the perfect square here. But 1404 lies between what and what? It lies between 30 square and 40 square. And if you see here, I want minus 3. I want the difference to be minus 3, which means it should be something like this. It should be between 30s to 40s. It should be either 33 into 36. What is the difference between 33 and 36? 3 is the difference, right? Or it should be 34 and 37, or 35 and 38, or the difference should be 3 basically. The difference should be 3. 36 and 39, 32 and 35. Are you getting my point? These are the possibilities. Okay, these are the possibilities. Now, what is the next thing? What is it ending with? What is the product ending with? The product is ending with 4. When will it end with 4 here? When will it end with 4? This will end with 0. 36 and 39 will end with 4. 5 and 8 will end with 0. 4 and 7 will end with 8. 3 and 6 will end with 8. So we can directly look into 36 into 39 if it is working out. Calculator idea? Can you check with the calculator if 36 into 39 is giving this? Is it giving 1404? 36 into 39? Yeah? Yes. So directly we can say that x square, then put the signs accordingly. Plus 36x minus 39x minus 1404. Instead of factorizing it and then doing, we can use some kind of a short approach. short approach. I'll just give you one more example on this or two more, and then we will go into the vectors part. Okay? Say for example we have 4x square plus 5x minus 636. What is the first step? First step is we need to do 4 into 636. Am I right? First step is we need to do 4 into 636. 636 into 4. This calculation we cannot get rid of. 4 6 24, 4 3 12 plus 2 14, 1 goes up 25. Correct ag madidina? 4x square plus 5x minus, sorry, yeah, the question is the same. What is my number? 2544. Lies between what and what? Lies between 50 square and 60 square. Or is it closer to 50 square basically? It's very close to 50 square. What's the difference between the numbers? The difference between the numbers is 5. The difference between the numbers is 5. So 47 into 52, 48 into 53, 46 into 51, 45 into 50. What have I missed? 45, 46, 47, 48, 49 into 54. The difference is 5. What else? 50 into 55. It has to be one amongst this. Where is it ending with? It is ending with 4. 48 into 54 Bharata. It is ending with 4. When will it end with 4? This will end with 4. What about 47 into 52? 7 into 2. That will also end with 4. Am I right? This will also end with 4. This will also end with 4. So you'll have to check which one of them is correct. Alright? Now you can't give a direct answer. You have reduced to 48 into 53. It is the options are reduced to 2 options now. You're getting my point? Whenever we come across big numbers, then what will happen? Then there is a possibility that we can solve it a little more quickly. There is a possibility that we can solve it little more quickly. Okay? Okay, all right. Now we'll go to vector algebra. Inna nange tale keritane ide eno miss madibitidini anta previous trick alli. I'm trying to recall. I just try to go right, then I like okay matte yak adu idu helada anta. Anyways, as I told, I'll tell you about that. It's not striking my mind immediately. So now we'll go to vector algebra. Sir was telling me that to do some questions or to do some concepts first we'll discuss some formulas on dot and cross product, and then we will solve some problems based on the same. Now, obviously we know from vector algebra that vectors don't behave like normal numbers, correct? The algebra that we do for vectors or the arithmetics that we do for vectors is not like normal numbers. So what do I mean by that? Say for example, when I have two forces acting on a body, we know that force is a vector quantity. When two forces are acting on a body, alright, say one is F1 which is 10 Newton and say one is F2 which is say 30 Newton. What is the total force acting on the body? What is the resultant force going to be? Yes, resultant is going to be 40 Newton. So here we could directly add the forces. Why could we directly add the forces? Because the forces were acting in the same direction. We could directly add the forces. But when the forces are acting in different directions, I just can't add it. Say for example, I have one force to be 10 Newton and I have one more force here which is 25 Newton. What is the resultant force now? 50? Okay. So we can't give the direct answer for the resultant force. Can anyone tell me why we can't give the answer for the resultant force directly? Yeah? Anyone? Why can't we give the answer directly for the resultant force? Because there's a different direction. Both the forces are not acting in the same direction. Because the forces are acting in different directions, there's a certain angle. Let's not go with the angle. Because the forces are acting in different directions, You can't just add the forces. Like how you add the normal numbers, you can't just add the forces. So what happens in vector algebra? What happens in vector algebra? Whenever there are vectors which are acting in different directions, you can't just add them as the regular numbers, you can't just multiply them as regular numbers, and so on. The arithmetics or the algebra for vector is going to be different. So today's class we will be studying about the dot product of two vectors. Today we'll be studying about dot product of two vectors. I think the dot product is done. What is the formula for dot product? If I have two vectors A dot B, what is the formula going to be? Yeah? Yes? Yes, it's going to be magnitude of A into magnitude of B into cos theta. What is theta here? It is the angle between the two vectors. It is the angle between the two vectors. So whatever two vectors we have, A vector and B vector, if theta is the angle between the two vectors, then A dot B is given by magnitude A, magnitude B into cos theta. All right. So obviously, if I want to find out the angle, cos theta would be A dot B by magnitude of A into magnitude of B. Now, A dot B, is it a scalar quantity or a vector quantity? Whatever result I get, is it a scalar or a vector? Illappa, vector agala, it is going to be a scalar. Whenever you do A dot B, what result you get? You get a scalar result. It's not a vector result, you get a scalar result. So this is about A dot B. Now, what are I cap, J cap and K cap? What are these? Okay, they are unit vectors. As one of you told, they are unit vectors in which particular direction? Along x-axis, y-axis and z-axis respectively. So they are unit vectors. These are unit vectors along x-axis, y-axis and z-axis respectively. So when I do I dot I, what will be the result? It is going to be 1 because magnitude is 1, and what about the angle? Angle is going to be 0 degree and cos of 0 is going to be 1. So I dot I, similarly J dot J and K dot K and K dot K, it's going to be equal to 1. It's going to be equal to 1. And what happens with I dot J then? Yes, because the angle between them is 90 degree. I dot J, J dot K and K dot I, all are 0. And one more thing, I dot J, J dot I, will the result change? A dot B, B dot A, will the result change or will it be same? A dot B and B dot A? It will be same. A dot B and B dot A same. So what can you tell? We can say that it is commutative. We can say that dot product is commutative. What do you mean by commutative? If you reverse the order of multiplying, then the final result is not going to change. The final result is not going to change. All right. So there are some more formulas with respect to the cross product. Sorry, with respect to the dot product. So one of the formulas is if the vectors are given in the component form. If the vectors are given in the component form, say we have vector A to be given as A1 I cap plus A2 J cap plus A3 K cap. All right, the vectors are given in the component form. What do you mean by component form? It is given along the x component, y component and the z component, z direction. And say vector B is B1 I cap plus B2 J cap plus B3 K cap. Okay, what happens with A dot B then? What is the formula? What's the formula? A1 B1 x component multiplied to x component plus A2 B2 plus A3 B3. Now, can anyone tell me why we write it in this format? Why are we writing in this format? What does it mean? A1 I cap, A2 J cap, what does it mean exactly? Can anyone tell me? Okay, have you come across the word position vector? What do you mean by position vector? What do you mean by position vector? Yes? Any idea what is position vector? Nipani, 20 boys, can you answer? ಹೇಳಿಪ್ಪ ಏನು ಗೊತ್ತಿದೆ ಹೇಳಿ ಪರವಾಗಿಲ್ಲ ಏನು ಗೊತ್ತಿದೆ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಬಗ್ಗೆ Okay, from origin to the particular point. Now what happens is, okay, so whenever we talk about vectors, we always need to have a reference point. Why do we need to have a reference point? Because if I have some object, say there's an object in your classroom, consider the screen itself. If I ask you what is the position of the screen, what will happen? Different people will give me different answers. Some of you will tell me that the screen is at this particular angle and so much distance from me. Then some other person will tell that the screen is nearer to me at this particular angle. Everyone will have a different answer. So it's always important from the physics point of view that you need to have a common reference point. So what happens? We consider origin as the reference point. So what exactly we mean by a position vector? If I have a point P, and now we are talking about three-dimensional geometry. We are not talking about two-dimensional geometry, we are talking about three-dimensional geometry. So what happens? There is an x coordinate, there's a y coordinate, and there's a z coordinate for that particular point. Okay? Now, if I have to say what is the direction of this vector, or if I have to say the position of this vector, I will draw a line from where to where? I will draw a line from the origin to that particular vector. So a line joining from the origin of the vector, from the origin of the coordinate axis to that particular point P, OP vector is called as position vector. Which is the start point here? O is the initial or start point. And what about the point P? It is called as end point or terminal point of the vector. So how do we write it in the vector format? If I have to write it in the vector format, OP vector is going to be, what is the x coordinate of that? X into I cap plus y into j cap plus z into k cap. As I told, I cap, j cap and k cap are what? They are unit vectors along x, y and z direction respectively. So that is why whenever I write a vector in this particular format, what does x, y and z represent? They represent the coordinates of that particular point with respect to what? With respect to the origin. So that is what has happened here. We had the vector A. So what about the coordinates of vector A? What will be the coordinates of vector A according to this? Yes, A1, A2, A3. Similarly, the coordinates of vector B will be B1, B2, B3. Okay? And when I do A dot B, we are multiplying the respective x components, respective y components and respective z components. All right? So this is the formula for dot product in the vector format. Now, what do you know about projection of vectors? Is it already discussed? Projection of vectors. Discuss agidiyappa? Have they discussed in the classroom? Yeah? I didn't get you. What did you say? Projection helilo. Okay, let's understand what do we mean by a projection now. Okay? But I think you told the chapter is completed. Yes, Nipani? Is the chapter completed? They did not tell anything about projection? Told. Sorry pa, enanda? Oh, not here. You are telling it is not told here. Okay. In college it is mentioned. What do you mean by projection of a vector? Okay, all right. So what happens is, we'll understand the meaning also. He told me the formula, which is correct. Now, when I say, there are two vectors. When I say projection of B vector on, say, A vector. Say I'm talking about projection of B vector on A vector. So what do we have? We have two vectors now. We have two vectors. Okay, I have B vector and A vector. Now, what do we mean by projection of B on A's? Say for example, the A vector is along this direction. A vector is along this direction. Say I have one more vector B, which is along this direction. Okay, we have A vector and we have B vector. A vector is along a certain direction. B vector is also along a certain direction. When I say projection of B on A, what does it mean is, I am talking about, is there a certain shadow of B on A? Will this be the shadow of B? Yes? Yeah? If I take, say for example, there is some source of light here. Say there is some source of light here. Now what will happen if I talk about the projection of B on A? I'm talking about what? I'm talking about the shadow of the vector B on vector A. This is what we are talking about. So this is called as projection of B on A. Now if I have to find out how much this particular shadow is, okay now, then projection of B on A is given by A dot B divided by what? Magnitude of A vector. If I have to find out how much is this length, basically we are talking about what? We are talking about the shadow. Shadow of which vector? B vector. On which vector? On vector A. It's given by A dot B divided by A vector. Any idea how we came to this formula? Or why is this the formula? Any idea? Okay, see here, from physics you have learned, if this is say theta, what is this particular length? B cos theta or B sin theta? According to physics, it's going to be B cos theta. You have done it, right? Resolution of forces you have done. If there is a force which is making an angle theta with the x-axis, then along the x-axis you have F cos theta, and along the y-axis you have F sin theta. So this is going to be what? Basically this is going to be B cos theta. Do you agree with that? Yeah? Yes, we agree with that. Now, so basically we are talking about what? Basically we are talking about B of cos theta. Now, going back to the formula. What is the formula? How can cos theta be written as? We had written it somewhere. Cos theta can be written as A dot B divided by magnitude A, magnitude B. So, yes. So, in the place of cos theta, if I substitute A dot B divided by magnitude A into magnitude B, what will happen to magnitude B? Magnitude B will get cancelled. All right, magnitude B will get cancelled, and what are we left out with? We are just left out with A dot B vector into A vector. So this is called as projection of B on A. If I talk about projection of A on B, it is going to be the other way around. Projection of A on B will be what? A dot B divided by what? The magnitude of B vector. Whatever we write next, that will go to the denominator. Whatever we write on, that will go to the denominator. Same thing has happened here also. Projection on A vector magnitude will go to the denominator. All right. So now we'll solve some simple problems on this, and then we will go ahead. We'll go ahead with the vector product. Okay, let's take up a problem, projection problem. We'll solve to find out the projection. All right. Okay, let me take any random example. Should not matter. Let me take any random example. So find out the projection of of 2i cap plus 3j cap minus 4 cap on I cap minus 3j cap plus k cap. Find out the projection. Can you solve it? Okay, consider one of them as A, one of them as B. If you're confused, illa direct ag ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ direct ag ಮಾಡಿ. So projection of A on B andre A dot B divided by magnitude of B vector. A dot B, how can we do A dot B? By component form. Bandhi the answer? Can anyone tell me the answer? Anyone please. Helipa? Minus 11 by root 11 ಬರ್ತಿದ್ಯಾ? Okay. Yeah, A dot B ಮಾಡಿದ್ರೆ 2 into 1 2, then 3 into minus 9, then minus 4 divided by square root of 1 plus 9 plus 1. So it's going to be, as you told, 2 minus 13, which is minus 11 by root 11. In case I rationalize it, ಎಷ್ಟಾಗುತ್ತೆ? Minus root 11 is going to be the answer. In case we rationalize, it's going to be minus root 11. Okay? Yeah. Now, next thing. Any questions? We just took up a simple example. On projection, we just took up a simple example. Okay? All right. Now, if I say that A1, A2 plus B1, B2 plus C1, C2 is equal to 0, what can you say about this particular? They are perpendicular because from the component form, what is happening? It is going to be equal to 0. From the component form, the dot product is going to be equal to 0. That is why we can say that the two vectors are perpendicular to each other. Now we have a formula for cos theta. We have a formula for cos theta only in terms of the components. Only in terms of components, we have a formula for cos theta. Okay? Now, say for example, we have two vectors. Let me take two vectors. A vector is, say, A1 I cap plus A2 j cap, A2 j cap plus, say, A3 k cap. And say B vector is B1 I cap plus B2 j cap plus B3 k cap. Okay? As I was telling, we have a formula only in the component form, and the formula is going to be, anyone knows the formula for cos theta only in the component form? Anyone? Okay. So A1 B1 plus A2 B2 plus A3 B3 divided by same thing. This is what? This is A dot B. What is magnitude of A? What is the magnitude of A going to be? Root of, yes, root of A1 square plus A2 square plus A3 square into root of B1 square plus B2 square plus B3 square. Yes. Okay. Now, what exactly do we mean by magnitude? Magnitude andre, say for example, we have any position vector. If I know the coordinates, we can write the position vector. If I know the coordinates, we can write the position vector. What exactly do we mean by magnitude? Magnitude means what is the length of this particular line? What is the length of this particular line? That is what we mean by magnitude. And how do we find out the magnitude? Magnitude of OP vector will be given by square root of x square plus y square plus z square. That will give me the magnitude of OP vector. And what do we mean by magnitude? Magnitude is nothing but the length. Magnitude is nothing but the length of that particular vector. All right. So tomorrow we will be discussing vector product, and we'll be solving some problems based on vector product. All right.
Okay, sir.
Yeah, and that particular thing I'll confirm tomorrow. Okay. Whatever that shortcut, still I'm breaking my head. I'm unable to recall. All right. That's not a problem. I've gone wrong. I agree with that. That particular part, I will correct it. Okay. I'll give you whatever the other shortcut is. Okay. Yeah. Bye, students. Thank you. Feedback kodbek. Everyone should give a feedback, it seems. Feedback is compulsory for the next class. Okay. All right.